This video covers question 4, part C from the 2021 AP Calculus AB free response section, no calculator allowed portion. I cover A, B, C, and D all in their own individual videos, so if you want to see A, B, and D, feel free to check out those other videos. So the first thing I do whenever I have a graph on any AP Calculus question is I make sure I know what this is the graph of. This is the graph of f of x. They'll switch up what it is, so always just make sure you know what you're looking at. So then from there, let's go look at what the actual problem is wanting from us. We need to find the limit as x approaches 2 of this formula here of g of x over x squared minus 2x. The first thing that I do on any limit problem is I just call it option 1. I take that x value and I pop it into wherever it needs to go inside this equation. So what we'd be looking at here, if I plug in 2, would be g of 2 over, and then plugging 2 in on the bottom, I get 2 squared minus 2 times 2. So on the bottom, I'm going to get 0. So kind of bells and whistles are going off that option 1 isn't going to work. But I need to kind of keep looking at what the top is, because if we end up in a 0 over 0 situation, that's what we call an indeterminate form, and we can apply L'Hopital's rule. So I come through and I need to figure out what does g of 2 equal. So this goes back to just finding my g equation. There's my g equation. So g of x, they've told us, is equal to the integral from 0 to x of f of t dt. Well, I want to know specifically what's happening at g of 2. Well, function notation works the same no matter if it's a nice easy equation like we see with like x squared minus 2x, or if it's got an integral in it. The way function notation works is whatever I replace x with here, you replace x with in the formula. So we just do it. So this is the integral from 0 to 2 of f of t dt. And so what we can now see is that we just need to find out what the value of this integral is. And this is the integral here is asking us to find the area between the curve and the x-axis from x equals 0 to x equals 2. So if we come up and look at our graph here, notice again, this is talking to us about f of t. F of t, f of x, they're the same graph. And so this time we want to know what's happening as I go from 0 to 2 right here. Well, if we look real quick, we can see that what we have is we've got two different triangles. Remember, area above the x-axis is considered positive area, and that area below the x-axis is considered negative area. And really what we have going on here are two triangles that are equal to each other, and they would cancel each other out. If you needed to work the math out because you just didn't trust your eyeballs to do that real fast, you'd need to know the area of a triangle formula. The area of a triangle, remember, the area formula for that is 1/2 base times height. So if I did this all by hand, I'd get 1/2. The base along the bottom of that first triangle would be 1. The height would be along here would be 4. And then I would be adding that to my red triangle area. So then that would be 1/2. The base along that would be 1. And the height here this time would be -4. And so now we can see a lot more clearly. I end up with +2 minus 2, and so I get out of there 0. So g of 2 is going to equal 0. Bringing that back up here and popping that in, I'm in a 0 over 0 situation. And when you're in 0 over 0, that's an indeterminate form. And what that means is L'Hopital's rule applies. So then you say to yourself, well, I hope I remember that when I go in to take the test. You can't forget L'Hopital's rule. What does L'Hopital's rule say? Well, if we talk about L'Hopital's rule, I'm just writing it as shorthand, LHS, because you don't want to write that whole thing out. L'Hopital's rule says if I have the limit as x approaches some number of f of x divided by g of x, if I get out of there 0 over 0 or infinity over infinity, I can now apply the rule. And the rule tells me that this limit here is going to be equal to the same value as if I had the derivative of the top divided by the derivative of the bottom. So to apply L'Hopital's rule, I'm now going to go take my derivatives. So this would be the limit as x approaches 2, taking the derivative of the top, the derivative of g of x, that's just a notation game. That would be g prime of x. Taking the derivative of the bottom now is just going to be a power rule. I bring the 2 down, that's going to get me 2x, subtract 1 from the power, gets me x to the first. And then on the second piece, I got an unwritten 1 for my power. I bring that down, 1 times negative 2 gets me negative 2. And then technically I would get x to the 0, but anything to the 0 power is 1, so I don't need to write that. Once I've done it, now I'm back to option 1. Go ahead and plug 2 in everywhere. So I get g prime of 2 divided by, plugging in 2 on the bottom, I get 2 times 2 minus 2. So the bottom now is going to get me 4 minus 2, which is going to get me 2. Well, I know I'm not going to have either one of my indeterminate forms here, so I'm feeling good about that. I just now need to come back through and figure out what g prime of 2 is equal to. If you watched my earlier videos, you kind of already know the punchline of this, but if this is the only one you're watching, we'll go ahead and run through the full process. So we come back to what g of x was equal to, right? So g of x is equal to the integral from 0 to x of f of t dt. So if I take the derivative, because I need to find the derivative of g, if I take the derivative of both sides here, the derivative on the left side, that's going to equal, the derivative of g is just g prime of x. The derivative on the right side, this is the Fundamental Theorem of Calculus Part 1. Whenever you've got an integral that's going from a number up to x, up to an equation like this is always the Fundamental Theorem of Calculus Part 1. And what that says is basically a derivative and an antiderivative cancel each other out, and that x just drops into whatever that equation is. And in this one, it's just f of x. So what I know is g prime of x is equal to f of x, which means that g prime of x is also the same as this graph over here. So when I want to go find what is g prime of 2, it's the same as asking me what is f of 2. So I just want to find the y value off of the graph at f of 2. So I got a lot going on here. Luckily I can erase it all to kind of get a better look at 2 now. So at 2, I get out a y value of negative 4. And so that's what g prime of 2 is equal to. So I can plug that in up top here. And in the end, I end up with negative 4 over 2, which is going to give me negative 2. And so that's equal to the limit that I started with. Because of L'Hopital's rule, I know the limit as x approaches 2 of g of x over x squared minus 2x is going to equal negative 2. And that would be my final answer for this question. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.